Hello everyone, welcome to Ghiloo and welcome to a brand new chapter called Continuity and Differentiability. Serves as an important part in Class 12 NCERT Mathematics. Now you have had a touch of it in Class 11. Here it is in a much extended and broad sense. So exercise 5.1 starts with proving that the function is continuous or discontinuous at some points. So before proceeding, let us have some idea about continuity. We will be having a graphical idea. Now for any function to be continuous, it is a very simple criteria that you should have to draw the function without removing your pen. If you can do this, the function is continuous. So if I say that the function is continuous at this point, it means that the right hand limit and the left hand limit of the function should tend to a single value, and the value of the function at that point should also be the same as that of the limits. That's all. And this is precisely what we'll be doing here. If you want more explanations, I would be having a separate video lecture series where I'll be explaining each and every chapter in great detail. You can refer to it, but due to lack of time, I shall be starting here as problems, assuming that you know it. So in the first question, we need to prove that this function is continuous and at x equal to 0, x equal to -3 and x equal to 5. The function is fx is equal to 5x minus 3. So let us write it. The given function is f of x is equal to 5x minus 3. So first let us check it at x equal to 0. So at x equal to 0, first let us check the value of the function at f equal to 0, that is 5 times 0 minus 3, that is equal to minus 3. If we get the limiting value of f of 0 from the right hand side as well as the left hand side to be minus 3, we can conclude that it is continuous. So therefore limit of x tends to 0, f of x, that includes both the RHL and the LHL, because the definition is intact, both LHL and RHL must come to the same value. So this is equal to limit of x tends to 0, 5x minus 3, that is equal to 5 times 0 minus 3 equal to minus 3. It is a plain polynomial function, so the limit can be extracted very easily. So therefore limit of x tends to 0, f of x is equal to f of 0. Hence we can conclude that f is continuous at x equal to 0. In a very similar way, we can also find it for points x equal to minus 3 and x equal to 5. So at x equal to minus 3, f of minus 3 is equal to 5 times minus 3 is equal to minus 18. In the same way, exactly the same way, limit of x tends to minus 3, f of x is equal to limit of x tends to minus 3 of 5x minus 3, that is equal to 5 times minus 3, which is equal to minus 18. So therefore limit of x tends to minus 3 f of x is also equal to f of minus 3. Hence f is also continuous. So similarly I am doing for x equal to 5. I think this needs no further explanation. So we are done with checking the continuity. So we have proved that it is continuous at all the points. Alright, now coming to the next question. Coming to question number 2, this is a very simple question. We have to examine the continuity of the function at x equal to 3. So this is exactly as the first problem, and it is even easier than the first problem. So once again we start with the given function is f of x is equal to 2x square minus 1. So first let us check the value at x equal to 3. That is f of x is equal to f of 3 equals to 2 times 3 square minus 1. So that gives us 18 minus 1, and that is 17. And now limit of x tends to 3, f of x. See, we are not calculating the left hand limit and the right hand limit separately, because the function has no change in definition. If the function had change in definitions, we need to consider the left hand limit and the right hand limit separately. So that is going to be equal to limit of x tends to 3, 2x square minus 1 is equal to 2 into 3 square minus 1 equal to 17. So as we can clearly see that limit x tends to 3, f of x is equal to f of 3. That means in a graph, if this is x equal to 3, the limiting value both from LHS and the RHS, the value that it is tending to is same as the value of the function. That's why there is no need to lift of the pen. We can draw it without lifting of the pen, and hence it is continuous at x equal to 3. Alright, so let's keep up to this today. We'll be catching up speed because there are too many problems, and we shall be solving next questions in the next video. Thank you very much for watching this video.